Let's look at our review problems. So in this situation, we have two blocks. So we have block A and we have block B. And block A has a mass of 1 kilograms. And block B has a mass of 3 kilograms. The blocks are forced together, compressing a spring between them. Then the system is released from rest on a level, frictionless surface. The spring is not fastened to either block and drops to the surface after it has expanded. Block B acquires a speed of 0.5 meters per second. So that's going to be VB prime after the spring or the event. What is the final speed of block A, and how much potential energy was stored in the compressed spring? So this is number 1 from our review. So again, this has to do with conservation of momentum. So we know MA, we know MB, we know VB prime, and we want to find MA. So this is what they call a recoil problem, because this momentum is going to be equal and opposite that momentum. When I write my equation for conservation of momentum, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. Remember, the equal sign is the event. So in this case, this is when the spring that's forced together is then released from rest. So that's the event. So this is before and this is after. So the key to these types of problems is both initial velocities are 0. So VA is 0 and VB is 0. So this whole term goes to 0. Instead of just substituting in, we're going to rearrange our equation to solve for the unknown in terms of the known. In this case, is going to be VA prime, the velocity of block A after the compressed spring is released from rest. So I'm going to leave this on this side of the equal sign, and I'm going to move this whole term to the other side. So I'm going to have negative MB VB prime divided by MA is equal to VA prime. So when I substitute in my values, negative 3 kilograms times 0.5 meters per second divided by 1 kilogram. Now remember, momentum is a vector quantity, and it has both magnitude and direction. So in this particular problem, I'm going to use my standard Cartesian sign convention that says up and to the right is positive. So when I put all that in my calculator, I get VA prime is equal to negative 1.5 meters per second. So if this is positive, this means that this is just going in the opposite direction. Part B, now the question asks, what is the speed? So remember, speed is scalar. Speed is the magnitude of the velocity. So if they ask me the speed, I could just say it's 1.5. But if they ask me the velocity, I would have to then say the negative means it's going in the opposite direction. Part B, again, how much potential energy was stored in the compressed spring? So the potential energy stored in the spring, we know, is equal to 1/2 kx squared. Did they give us the spring constant in this problem? No. So we know that the potential energy is also equal to the change in kinetic, which would be the final minus the initial. So I can say 1/2 MAVA squared plus 1/2 MBVB squared. So then I can substitute in my values. 1/2. Remember, this is the final minus the initial. So the final kinetic energy, I forgot the primes, and the initial kinetic energy is 0 because VA is 0 and VB is 0. So I'm going to have 1/2 of 1 kilogram times VA prime, the velocity of that one, which we found was 1.5, squared, plus 1/2 of 3 kilograms times what we were given, 0.5 meters per second squared. So when we put all this in our calculator, the change in kinetic is equal to the potential, which comes out to be about 1.5 joules. So when we're first doing this, we're like, oh yeah, potential energy, 1/2 kx squared, but we don't know k. So we have to think, what is another way that we could do this problem?